Next thing on the podcast this month is we're going to have a quick chat with Tom, who's kindly come from Garmin. We'll talk a little bit about magnetic north, because it's been in the news recently, Tom, hasn't it?
Yeah, so it seems to have moved quite a lot.
It's moved quite a lot, so it's been in the mainstream media as well as it. So, first of all, Tom, what is magnetic north? So just know what we're going to be talking about.
So there's kind of 3 different types of north that we use.
Okay.
So the first one is grid north. So that's the blue lines on your Ordnance Survey map, where they've gridded the Earth, as it were, and that's the direction that they point the line directly north of those. So that is grid north. You've then got true north, which is the actual North Pole.
Yeah.
So that's slightly different from the gridding.
Yeah.
And then you've got the third one, which is the magnetic one, which is where your compass points. So that's the actual magnetic North Pole, and that's the one that's moving.
Yeah. Do you know how magnetic north is going? I'm not going to baff it. I just researched a bit on it. Magnetic is created by magnetic minerals in the crust of the upper mantle, it says.
Yes, is it the moving round of the
as well as
core?
creating the flow of seawater, but these influences are small compared to those of the core field, according to the 2015 result by the World Magnetic Model.
Wow, there you go. Every day's a school day.
It is every day is a school. I've got into this morning. This is quite a fascinating subject when you get into magnetic north. So magnetic north varies, doesn't it? That's the key thing, isn't it? And it moves usually slowly. But then in 2014, this year, there was a change, which is something we've not seen since 1660, isn't it?
Yeah. So I think there's a couple of agencies, isn't there, that calculate the slight changes in magnetic variance throughout the year, and obviously it can affect quite a lot of things. So you've got quite accurate compasses in things like aeroplanes and boats, as well as the things that we use in our handheld compasses. So they do have to adapt to it each year, don't they? But yeah, there's been a big swing, hasn't there?
In 2014, it moved from being over on from the west to the east. No, from the west of the grid north to the east.
Yeah.
So it went across axis, so instead of alternating to east, it's now moved west or vice versa. There, wasn't it? That started off in the southwest corner of Britain, and that's slowly moving because it varies, doesn't it, whereabouts you are in the country? Yeah,
so I was just having a quick look. There's an online website, Magnetic Declination, where you can work out.
I'm not recording it. Facebook people, you can see this again.
There you go. There's a
I just looked at the recording there and went, that was good.
And it was all going so well.
It's all going very well. So, start again. So, Facebook people, to see how we do make mistakes sometimes. I just looked at the record and thought, that's not working. Right, start again.
And we all know it now.
The next thing on the podcast this month is we're going to look with magnetic north. So Tom's kindly joined me again from Garmin, and thank you very much for Tom for joining me. And we're going to look at magnetic north. So initially, Tom, what is magnetic north?
So magnetic north is one of the 3 different types of north that we use in outdoor navigation, and that is actually where your compass points. So it's the direction, most northerly direction that your compass points to. The other 2 you've got is true north.
Yes.
So that is the actual centre axis of the Earth. And then you've got grid north, which is where the blue lines, the northerly blue lines on your OS map or your map point to, which is kind of grid north. So 3 different types.
Okay. And the key thing in magnetic north is it does vary, doesn't it?
Yeah, it's not actually at the North Pole.
It's not the North Pole. It varies according to where you are in the country.
Yep.
And well, I suppose it varies on the big news story that's been in the news, and in the mainstream news, not just in the walking news. Actually, it started moving a lot quicker, hasn't it?
Yeah, than what they expected it to.
So then, what magnetic north? What creates magnetic north, Tom?
Go on.
Go on. It says I googled this morning, and there's other factors play a role in where this magnetic north is. It's magnetic materials in the crust of the upper mantle is the main thing it comes, as well as electric currents created by flow of seawater. And these are small compared to the core field. So it's the magnetic things in the upper mantle which does this. And this was a report that was done by 2015 report on the World Magnetic Model. So that's how it's creates this magnetic north. But again, I say it's slightly moving. And then back in 2014, there was quite a big change, Tom, in what we've got, isn't it?
So, yeah, it kind of apparently moved under Siberia. Is that
Exactly
Correct,
right.
and
So
it went over the axis, didn't it? So it went from a negative towards a positive.
just gone from west over to the east side, and that's the first time it's done that since 1660. So it shows how much that's moving, isn't it? Again, when it's moved, it starts off the southwest corner, Tom, doesn't, and moves across the country. Because as we go across the country, it varies reasonably a bit, doesn't it?
So there's a website. There's a couple of different websites you can use, but there's a website, Magnetic Inclination, where they've got a map, and you can click on your location or any location and see the magnetic inclination at that point. So there's kind of a line at the moment that kind of runs roughly by the M1.
Yes.
So kind of anywhere to the east of places like Nottingham, Leeds, Peterborough, are all 0 now. So there's actually no magnetic inclination. Grid north is the same as magnetic north at the moment. If you go west of there, you've got to take it's a -1, so it's further over to the to the west.
And I say why it hit the mainstream press a lot this year is they forecast how much is this going to move, and they got the forecast completely wrong because it's been moving at like just 9 miles a year, but then suddenly it's jumped up to 34 miles per year, this magnetic north, which has kind of thrown the whole lot in. So then coming back to us as compass users, well, magnetic north is magnetic north because that's where our compass is pointing towards, isn't it? But as GPS users, Tom, we've got options within our GPS units that we can change that to.
So the compass inside there is an electromagnetic compass, so it's using the magnetic field to give you that direction, but you can ask the unit to revert to grid north, true north, and work one way or the other.
I think really we need to address also why we got these compasses in why we got electronic compasses in a GPS unit anyway. What's the benefits of that?
Yeah, so the kind of true benefit is giving the unit an idea of direction when it's stood still.
Okay.
So if you can imagine, for the Facebook viewers it's really easy, but I'm holding the unit on the palm of my hand, facing away from me. From a GPS point of view, if I turn it around 180 degrees, from a GPS point of view, it hasn't moved, it hasn't changed, so it's got no idea that it's facing a different direction. But you're asking it to give you a direction that you're moving, even when you want to go when you stood still. So the compass does the slower speed, it aids the navigation at much slower speed, stroke standing.
And it's what we call a 3-axis compass as well.
It is, yes. You don't have to hold them level anymore or anything like that.
So a traditional compass we have to hold level, don't we? Is it alcohol in it there? Is alcohol in a traditional compass or water? Anyway,
distilled water.
Distilled water. That has to be kept flat, where with a GPS it's what's called a 3-axis compass. So
absolutely.
But we need to calibrate them.
We do.
We need to calibrate them.
Spinning them round, three different directions.
Make sure it's all calibrated.
Yeah.
So when we're setting up our units, how would you set it up? Because again, we've got the grid north, true north, magnetic north, and I think you also kind of put your own personal. You can
have your own personal one. Yeah. I think I'd stick with magnetic. It's going to be the one that works most with the compass that you should have with you anyway.
Yeah.
So kind of you're not confusing yourself by it giving you a different number to what you'd want to be working to in your compass.
Right.
We all should know the magnetic inclination roughly of the area that we're going to.
Yeah.
So then you can do that calculation either in your head if you need to, if you're using Sight and Go or something like that.
Brilliant.
But I'd stick with magnetic because it's then not going to confuse you if it's pointing slightly differently to what your compass
and all our setup sheets, well, the way we set our GPS units and the setup sheets we give in the online resource things, we always we'll select that as magnetic north really, to get the most accuracy. So it's a big interesting subject. I say it's interesting because it's been in the mainstream press. No one kind of stumbled across it in newspapers, been on the BBC websites, things about this big change in it. And I think looking at when I've been researching it this morning is I think because they had already predicted what they thought it was going to be, but actually these predictions were widely wrong.
Yeah.
So I've had to go back and look at this.
Yeah, it's something that we should all loosely follow. You know, for how well can we all take a compass out with us? We should know roughly how much to take on and off for a bearing. It's something that I might have been a bit lax in checking over the years until it's come to the forefront. I always just thought it was -3. And can crack on.
Let's get on with it.
Yeah.
Brilliant. All right, Tom. Thank you very much for joining me and to have this quick chat about magnetic north.
No problem.